Dear students, in this video, today we are going to discuss about capacitance of a parallel plate capacitor with a dielectric slab. In the previous video, we discussed what happens to capacitance of a parallel plate capacitor when we inserted a conducting slab. Now in this case, we will insert a dielectric slab. So let us see what will happen when we inserted a dielectric slab between the parallel plate of the capacitor. As we know what is dielectric, we discussed in the previous chapter. You can go to the playlist and you can find the explanation for dielectric. So in this video, we only discuss about how the capacity will vary for dielectric slab when we inserted it inside the two parallel plate of capacitor. So let us consider we have two parallel plate of capacitor. So we have two parallel plate of capacitor. The first plate is plate A and the second plate is plate B. Let us consider the charge on plate A is positive Q charge, and similarly the charge on the second plate B of the capacitor is negative Q charge. Now we will insert a dielectric slab between the two plates of the capacitor. Like the thickness of this plate, this dielectric slab is T, and how the electric field behave due to the positive and the negative charge of the parallel plate of capacitor. So because of this positive and negative charge, a field will generate, which we call it as a external field due to the positive and the negative plate of the capacitor. So let us give a name to the field. The name of the field is E0. We will give a name E0 to this field. So this field is outside the dielectric slab, but what will happen to dielectric slab? Because dielectric is made of small number of atoms and molecules. So all the atoms, electrons, or you can say charges, will arrange themselves according to the charge on the plate A and plate B. So here positive charge is there, so this positive charge will attract the negative charge toward the positive charge. So because of that, negative charge will develop here, and this side positive charge will develop. So here the polarization process occurred. If you want to know about the polarization process, you can see the previous lecture where I have explained the dielectric polarization process. So because of that, what will you see here? Because of polarization, a field, a internal field will develop inside the dielectric slab, and that field is due to this positive and negative charge. So let us consider this field is EP, and this is your external field E. That is your E0 field. But this E0 field is not present inside the dielectric. Inside the dielectric field is EP. So you can see the direction of the external field is this side and the polarized field is this side. So what will the net field inside the dielectric? So net field will be the subtraction of this and this field. So we can write here net field, we can give the name net field is E. So E will be equal to E0 minus EP. Okay, so net field inside this region is your E0 minus EP, because both directions are opposite. This side E0 and this side EP. So net field direction will be toward this side, because this vector is greater than this smaller EP vector. So this is your net field inside the dielectric. So now again, as in previous lecture I discussed the potential difference developed between the two plates of the capacitor, the same thing we will discuss here. So how the capacitor will develop, capacitance will increase in the presence of the dielectric slab. So first of all, we will find the potential difference between the two plates of the capacitor. So let us consider this V is the potential difference developed between the two plates of the capacitor. But here is a different field, or in this region the field is your E0, and inside the dielectric this is the net field. So the overall potential, how we will find? We find separate potential for this E0 field and for this E field, and we will add the two. So first of all, in the region where the field E0 field is present in this and this region. So what is the length of this region? The length of this and this region is, how will you find the length of this portion and this portion? The overall length is the distance between two plate is D. So this one is D and this one is T. So this the sum of this distance and this one is your D minus T. This is D minus T. So we will write here the distance is D minus T. D minus T is the length through which E0 field is spread. Plus, now dielectric slab is there and dielectric slab has some net field. So what is that net field? That is your E. That E is equal to E0 minus EP, but here I am going to write only E. And what is the thickness of this region? That is your, what is the thickness? That is your T. Okay. So now in the next step we will use this formula, that is for dielectric constant. We know the electric field in the vacuum with respect to medium is equal to K. K is the dielectric constant, K. So from this formula we can find the value of capital E. So what is E or E? E is equal to E0 by K. So substitute this value in this formula. So you will get V is equal to E0 T minus T, and substitute the value of E here. So what is the value of E? E is equal to E0 by K. So we substitute this E value in this equation. So in the next step, take E0 outside and you will left with D minus T plus T by K. Now we have to substitute, this is your equation number 1, and now we have to substitute this value of V in this equation. C is equal to Q by V. So substitute the value of V here. So substitute value, you will get E0 D minus. Before that we can do one thing, it will be easy to solve. So as you know, E is equal to E0 is equal to sigma by epsilon, the electric field between two parallel plates of the capacitor or two infinite parallel plates, and your sigma is equal to Q by A epsilon naught. So it means you can replace your E0 with Q by A epsilon naught. So I am going to substitute the value here directly. So what is your V? V is equal to your E0 D minus T plus T by K. In the next step, substitute this E naught value here. So what you will get? Q by, what is E naught? That is your Q by epsilon naught A, and the rest of the thing will come as it is, d minus t plus t by k. Q will cancel. In the next step, you can take t common. So d as it is, take t common, here 1 minus 1 by k. So in this way you will get expression for C. This is your capacitance of a parallel plate capacitor when dielectric slab is in between the. If you see this equation, D is in denominator and something is getting subtracted from the denominator. So if something is subtracting from the denominator, you will get a, this is a smaller term. It is getting smaller, it is decreasing. So if this term is getting decreased, so this will get increased. So that's why capacitance of a parallel plate capacitor increases when we inserted a dielectric slab between the two plates of the capacitor. Even you can compare this one with this. This is the capacity of parallel plate capacitor when there is no dielectric slab or no medium in between. So in this case there is no term which is going to subtract, but here this term is subtracting from this. So overall the denominator will decrease. If denominator will decrease, this C will increase. That's why we can say C is greater than C naught. So if you compare the two topic, first one when conducting slab is between the parallel plate and when dielectric slab is between the parallel plate, in both cases capacity will increase. So we conclude here the dielectric slab between the two parallel plates capacitor will increase the capacity of the capacitor. We can store more charge when a dielectric slab is in between the two parallel plates. Dear subscriber, if you like my channel, my video, my content, so don't forget to subscribe my channel, and if you want more videos, I will make new videos that is easy to understand to you. So please like and subscribe my channel, and which will motivate me to make the new video. Thank you.